Hello everyone and welcome to today's live stream where I will be going over all of the new nodes and changes for geometry nodes in Blender 4.3. Blender 4.3 is going into beta soon, which means that there will be only bug fixes, no new features. So this is what we have for 4.3 and it's looking very good. So let's go and take a look at the changelog. I should have gotten a better screenshot, but here is the changelog. Change 1. Geometries can be named now to improve data inspection in the node editor and spreadsheet. So let's take a look at that. We can use the set geometry name, put this up into here, and we'll just do geo1. And let's take a look in the spreadsheet. So let's go and do that, open up the spreadsheet, and we can see it is named Geo1. And now you can have multiple geometries. I forget if they have to be instances, so let's go and try that. Let's use a join geometry. Right here, it'll just be Geo1, and we'll label this Geo2. Seems like Geo2 takes priority over the previous name, so let's set this to instance, geometry to instance, so we can have 1 and 2. So if they're instances, you can have multiple pieces of geometry, which makes a lot of sense. So that is change 1. Change 2, support for gizmos has been added, which this I am particularly excited for, because this gives us the ability to have, well, gizmos compatible with geometry nodes, which will make tools very useful. So let's give a little demo of this. So the way you set it up is you have your gizmo, you feed it into an input, and it kind of creates a feedback loop, which you can see by the double lines here. So let's see what the end result is. In this case, I have a transform gizmo, which if we move this object and move it around like this, right now it's not following along because I have not put in the position and rotation inputs, but we can do that by simply dragging these parts into there. Now we can see that the gizmo is lined up. We can see by moving this around, it rotates, and all that works very well. This is a transform gizmo, which means that it gives a matrix output, or a transform matrix, same difference in this case, and puts that into the transform geometry node if it's a matrix. And then we have the linear gizmo, which is just an arrow in a given direction. In this case, this one will extrude the mesh. And then, after that one, we have a dial gizmo, which basically you can rotate it and it rotates. In this case, it is controlling the extrusion scale, which is very nice. A few other things with that, since it is a bit of a feedback loop, it can be a little bit weird when feeding it into the position and such, but if you see these double lines, that means that the values are in that feedback loop. It's a bit hard to explain, but you can see what's going on. There we go. Then over here, the dial gizmo can be a screen space effect, so if you zoom out, it'll be the same scale visually, but if you turn that off, it will always be, in this case, 1 meter, no matter how much you zoom out. The linear and transform gizmos are always screen space. I need to also check, there were a few settings in the right here. You can turn off some of the parts of the gizmo, at least the transform gizmo, in the properties tab of the node. So just like that. Let me check the linear gizmo. Yep, those seem pretty much the same. You can change the colors by changing the color settings. It's either primary, secondary, or X, Y, and Z. And this is in accordance to the theme that you chose. Let me go and make some more room up there. But yes, this is a very welcome change. It will make geometry node setups and tools much easier to use. Okay, so next up, we have the new node warnings to add custom warnings to node groups. So in this case, let's go back over to our setup right here. In this case, this is giving a warning because it defaults to true, and we can see that in the modifier it is showing up. It doesn't have a message, so let's give it one. Nothing connected. There we go, and we can see that that shows up. You can set it to warning, which will change the icon, or info, which has some special properties that I kind of forgot about. But I believe info will not show up in the modifier, but will in the node groups. But I would have to double check on that. You can have just a setting control that, so let's go and put it over here in our very very complex demo room right here. Let's make a switch node because that will become important later. Switch. There we go. And let's have, I don't know, a certain setting. So let's use domain size. So if the domain size is greater than 1, or, yeah, greater than 1, it will show, oh, geometry. Well, actually, no, empty. So if it's less than 1, it'll show up as empty. There we go. So if I were to delete, let's also get rid of this node warning. I'll just switch it to info for now. After we get rid of all the geometry, we can see that this reads as empty, which is very nice. And then if you go and connect this to, I don't know, another setup, you can make it so that it'll switch over to something else. So in this case, let's go and get a cube. There we go. So if we delete all of this, it'll give the warning that's empty, and then cause the switch to a cube in this case, which is very nice. Okay. Let's go over to the hashed value node, which is also very, very nice. There we go. Let's see, live again. I think this is the 4th stream today. A couple of the streams had technical issues, so I had to close them out within the first 2 minutes. This one is take 2 of showing the geometry node stuff, because the previous one I did not do my research and did not prep for it. And then the other one was the rigid body dynamics branch, which I would recommend you take a look at. That one is not going to be in 4.3, it's an experimental branch, but it is very cool. So I would recommend taking a look at it. Okay, where was I? Oh, the node warnings, yes. Let me go and re-add in the plane so that I can actually select our dummy object. Okay, so the hashed value node, yes. So the hashed value node will basically give you a random integer, signed 32-bit integer, I'm pretty sure, given an input. So let's go and take a look at the viewer. Let's see, let's go over here and show attribute text. So here we can see every single part here has a random integer. At the moment, they are all the same. So let's have, I don't know, the index be the first one here, so we can see all of these have different numbers. I hope that's showing up on stream, but the power that this node has, rather than just the random value node, let's see, random value, let's set this to be integer. You can see that they have some similarities with the ID in the seed, but this one is more generalized. So this could be a float, where if there's just a different value, say, I don't know, the x position, so let's try that. Position, separate x, y, z. It will give you a different integer value, which can be very nice. So here we can see that they are the same only on the x-axis, but on the y-axis they're the same, but on the x they are different. And then you can change the seed, but this also extends to vectors. So you can have the position data translate into that, which previously was not reliable using the random value node, and because you would have to convert a position into integers, but this just takes all that guesswork out of it. You can have it as rotations, matrices, strings, or colors, which is very, very nice. So you could have, actually that's very powerful, we haven't really had that before, where you could just have a string and it'll convert it into a random hash. So I guess you can make a setup where like it iterates through all of the named attributes that you have. And then it'll give a different result based on that. White noise does that. White noise does do something similar where it has 3D, 2D, 1D, and I guess 4D. Wow, I forgot 4D existed. But it'll give you just a float value, while this one will give you an integer value. So in that case, they are similar. This is just more generalized and gives you an actual hash, which is much more reliable than trying to convert a value between 0 and 1, which is a float. Okay. So node timings are more accurate now. I have not tested that yet, but that should be very good, especially with one of the nodes that we'll go over later. Bakes made with the Bake R simulation nodes can now be packed into the blend file. I'm very excited about this. This is a great change. Before, all these simulation bakes and regular bakes would be... Well, I'm not sure about regular bakes. All the simulation bakes would be outside of the blend file, which means that if you were to copy it or move it, they would get disconnected and it was just weird. Now they can be packed inside the blend file for better stability and while transporting files, which is very, very nice. Next up is the integer math node. Now this one is very nice, similar to the hashed value. Instead of working with float values, which are susceptible to float point precision errors, it now can work with integers, which are much more reliable. Integer math, here we go. So I guess these are somewhat related in a sense, just in their differences. So here you can just have an integer value in, and it'll give you, an output. It's just regular math. Here are the functions inside of it. I don't use, with the node setups that I usually do, I don't really rely on integers that need to be ultra precise, but I have seen people that do that, and this node is very welcome. It is a 32 signed integer. So basically what the hash value deals with, that can deal with very well, and you don't need to worry about things breaking down when the floats get out of hand. So that is a very welcome change and will make geometry nodes much more reliable when dealing with the very precise effects. Okay, so after that we have the new for each geometry element zone. Now this node allows for just new functionality, just things that are much, much better. So here is the classic example that I've been using, where in this case, we're basically recreating the attribute text function, but with actual geometry that you can render and use, and you can do so much more. So with the string to curves node, usually you would just have one string and then it would just output something, which is good. But how would you do that for every single point on a piece of geometry? Before, you would have to use the repeat zone, which would be extremely expensive and very just cumbersome to use. But now, with the for each geometry element zone, it just works in a few nodes. It's a very elegant solution, and it is much faster because the calculations are done in parallel and don't recalculate things when they don't need to, which the repeat zone would do. So in this case, we're taking the points of this icosphere and bringing them in, and then we also convert the positions into singular values. So think all the fields, all the varying values just can get converted into singular values inside this area. You can also access the actual point with the element input, or I guess output. It's kind of weird with zones. In this case, we're not using that. We're just taking the index of the geometry, turning it into a string, changing the string to actual curves, and then moving those to where the point is, as we can see here. And then that geometry is then output. There are two geometry outputs, as you can see here. This part is a little bit confusing, but if I remember correctly, the devs are naming this to be a little bit clearer. Up top here is the main geometry, which is unchanged except for attributes. If we were to do something to this attribute, like, I don't know, add a bit and then put it out there, it would be the original geometry with changed values. I'll need to double check on some of that because I think that should be a singular value, but I'll have to check up on that. From what I've heard, let's go and take out that output right there. It should be the original geometry with some varying data, if you decide to do that. And then the bottom output is all of the new parts, the parts that were made for each point in this case. So you can have it so that the points are extruded and those extruded lines go out here, but that relies on separating the geometry into its individual elements and then recombining them. So in this case, it could be a little bit expensive, so choose what operations you want to do with the element and the outputs here, because it has to separate the geometry and combine them, which in some cases you really, really want, and in other cases, well, you don't need to. But in this case, all of these string to curves are being joined into one, not necessarily one geometry because these are instances, but they are being joined into one geometry flow. And then I fill the curve and then send them outwards. And right here, I'm just deleting the faces so that we can see the numbers a bit clearer. So that is the for each geometry element zone. There are a lot more things I want to try with this, and I would highly recommend experimenting with it if you've had a setup that you've wanted to do for a while, and it's just like, oh, how would I do this for each point, and stuff like that. Oh, another thing. It's very nice that you can just switch out the element that's being operated on. In this case, you can just switch it from point to edge to face. Face corners are a little bit funky, but in this case they work well. There's just a lot of numbers in there. Spline, instances, and layers. So this is a very, very welcome node. Okay, so with that, a few modifications. The skip checkbox in the simulation zone is hidden to avoid clicking on it, which I have done many, many times. This used to be a Boolean input where you could just check the checkbox, but that has now been hidden because, well, users don't really do that unless they're doing it with an input. But when you would click and drag, you would quite often hit the hitbox. So that is now hidden, so now just a nice quality of life changes. There are quite a few nice quality of life changes, which I am very, very happy about. There we go. Okay, what's next? The sculpt mask is now accessible in Node Tools. This part I don't really use all too often, because I do not sculpt often, which I probably should. But let's get the sculpt. Right, where's the mask? Let's see, types. Let's just enable all of that. Okay, mask. Let's see, or is that face sets? There's face area, face set. Maybe I don't have it in this build. My build is slightly old. I would recommend looking that up if you're interested in that. Okay, Grease Pencil. Geometry Nodes now supports Grease Pencil as a new geometry type. So let's go and try with a Grease Pencil object. Let's just go and get the classic monkey, bring it into here, switch from Node Tools to Modifiers again, and add in a Geometry Node modifier, and click New. This comes with the Grease Pencil to Curves node, so Grease Pencil to Curves. There we go, let's put that into there. Now this converts the Grease Pencil into curves, as you would expect with the layers being turned into instances. In this case, we have fills and lines as separated instances. Actually here, yeah, Grease Pencil, 2 layers right there, which is very, very nice. And then you can convert that back into Grease Pencil, curves to Grease Pencil right here. And the data transfers over very nicely. We can see that there is opacity and radius. Is there a color thing, or is that the material? Ah, it's the material assignment. So that's very... Oh, that means that curves support multiple materials now. Possibly. But yeah, we can see from the data types there that that works, so the conversion is seamless. You can convert the Grease Pencil into curves, use a set position to wobble it with noise. I wonder if geometry nodes can offset the Grease Pencil by default. I'll need to look into that. Let's see, let's go and scale. Let's use the position. Oh, that's because it's an instance. So we can realize the instances, or I can use a stored named attribute. I'll realize the instances in this case. But that messes up a few of the things. So if we undo that, we can see that we can displace this with noise. But if you want to affect the instances, or the geometry inside the instances and not the instances themselves, use a stored named attribute node and affect the position directly. So let's just go and add. So make sure that's on the point domain and you won't affect the original instances. One of the reasons I love the stored named attribute node. It's just the most generalized node out there. So here we can see the instances still exist and you can make them all wobble. So in this case, let me use 4D noise and then use scene time, and I'll go regular math divide, and then I'll floor it to make that kind of like alternating sketch look. And then we can scale this down. So now, yeah, that's very, very nice. You can make that kind of look. Now that did exist in regular Grease Pencil modifiers, which I believe, yeah, right here. It was wave distortion, I forget which one. But now you have that, and it's very, very nice. Now you can generate grease pencil stuff dynamically, and it'll work very, very, very well. Maybe you can even do some cool, I don't know, like tree generation with grease pencil. A lot of things I'll need to try out. But I'm sure many, many people are very happy about that. We'll just have that little guy in the background just dancing along. I'm very happy that you can convert grease pencil to curves and then back without any data being... I think without any data being lost. That's very, very, very cool. Okay, let's go and just fiddle with this a little bit. Okay, what is next? Okay, that's that part. Yep. New geometry type, various nodes supported already. Oh, right, I need to test if the set position works on just these ones by default. Yes, it does. So you don't even need to convert it, but I'll just keep it like that for now. Okay, next up, we have the nodes. Node groups now can have a default node width, which I know quite a few asset creators were really hoping for. Basically, in a node group, if you take a look at the node width right here, you can go and change it to be whatever you want, and also sample the current node width. You can set it to be whatever the current node is. So right here, in this smaller version of the node, you can click that and it'll change it to 140, and go over here and change it to be 250, whatever the current node size is. So we can go and increase that to like 700, and then when we go and add in a new node, which this is just a node group, it will be a absolutely massive node, which is very nice. Let's also go and just change the color tag to be, I don't know, a massive texture node. Yeah, that's very nice. And yeah, I believe these were the color tags were introduced in 4.2, which is very nice. I haven't been able to use them yet because I've been trapped in the older versions of Blender, but it is very, very good to see. Okay, let me reset that back to none. Let's go back over to here. Built-in nodes can have line separators now. In this case, this is basically, as far as I've seen, used only in the for each element zone. You just have a nice little spacer right here. You can connect it, and when you connect more into here, we can see that you get a nice little spacer. In the future, they may be able to be put into node groups, but not right now. Okay, panel descriptions show up when hovering over them now. I'm assuming that is for node group panels, so let's go and try that right now with a different node group because I don't want to edit that one too much. Let's add in a new panel and bring these two into here. So this panel description, hello world, and there we go. If we hover over this, it will go and show the description with a period added at the end. Very cool. So that's that. And now for a very, very cool one. String sockets can now use placeholders instead of labels to make the input field wider, which is one of the things I'm most excited for in 4.3. It's a little change, but since I use named attributes so much, it is very appreciated. So with nodes that have string inputs like the named attribute, stored named attribute, node groups, string to curves, just set geometry name, most of the nodes that have that now have this new setting on them. Where instead of before, where it would be like name and then test attribute or whatever the input was, where it would take up 40 to 50% of the area, it now has all of the area. So you can have a named attribute, which is big, which is very nice. As we can see here, it's test attribute, but gets cut off very early. And then in the new version, it's just test attribute, and there's so much space you can even include a folder icon. Now, this isn't in the notes, maybe it's in like the UI notes, but the file path setting right here is now a subtype of the string input. As we can see here, it's either none or file path, which can now, propagate into node groups. This is for the import nodes, which are also, I believe are they still experimental in 4.3? I don't think I see them in the changelog. Maybe they're still experimental, I'm not sure. They're in Blender 4.3, but you need to, last time I checked, you had to enable an experimental tab. Those had file path inputs, which could be just a string, or you can click this icon and it will open the menu. And now you can access it inside of node groups or the modifier, which I will showcase here. Let's add a new input, set it to be a string, and it can be a file path. So now the user does not need to go inside the editor when you're like importing different stuff, which is very, very nice. Very, very, very nice. Okay. Oh, also with the named attribute nodes, when you would make the node bigger, we can see that the amount of space that we're getting is a lot more in here than it is on here. I could write an entire novel in here just because here the distribution, I believe, was 40 to 50% between the name right here and the actual input. But now it's the whole thing. So the wider it gets, you'll get 40% more no matter how big it is. So you can name your attributes a lot more and it'll be better. And if you're wondering how I made it so that there's a name or no name, you just need to go and remove the name from here. And I guess this kind of replicates the in Blender 4.2 and before, in a group, you would go and take away the name to make all this available, which we would use as spacers back in the day. Now you can use that in node groups, which is very, very nice. And yeah, one of my favorite changes, just because since I use named attributes all the time, the attributes no longer get clipped. So much space. I am so happy about that. Okay, that should be pretty much all of the main geometry node changes in Blender 4.3. It is a great update, and I am very, very happy with it. The forage element zone will allow for many cool things, which I will try in just a little bit. I have a little experiment that I want to try out. If you have any questions, please ask them now. Let's see. Color tags are beautiful, yes. I've not used them much because I've not been working on Blender 4. I haven't been working in Blender 4.2 and onwards. I've been in the older versions of Blender still. But this will be very nice when I decide to either update my particle system, which needs updating. I need to update it to the Delta Time version. And I'll just be using this a lot for, you know, stuff like that. It's very cool. It's it's another step towards geometry nodes having really solid assets that you can just use whenever. Okay, what else? I feel like I'm missing something that I planned on showcasing. The hashed value is very appreciated. Integer math, I know a lot of people who are more into like the very precise math, the programming side, are very happy about that. Warnings are very useful for assets. If the user hasn't selected an object, you can say, hey, you forgot to select or assign an object to this situation here, and you probably should do that. Geometry names, I will find uses for that. I know that will be useful in the future. So many more possibilities, and even with grease pencil being added, that is a huge, huge update for those people who use that. Which maybe I'll get into that. Maybe I'll get into making grease pencil stuff, because that is really cool. Being able to... Actually, let me try a little bit of that right now. Let's go and make a mesh, and let's try to have a simple curve star. Yeah, there we go. Curve star, and convert to grease pencil. Let's go and do that, and do we see... Oh, what is this? Non-instance curves are ignored. Okay, so you need to do that. So these curves right now are just showing up. Are they rendered? Yes, they are. Okay. So these are just showing up, and they have thickness. Like, look at that. I guess these are GPU drawn, or just rendered curves, which are very, very light, which could be very cool for certain trail effects. I'll need to keep that in mind. I don't think they can support regular materials. Maybe I'll look into that. Actually, let's try that out right now. Set material. Let's go and try just a regular material 01. And yeah, okay. It's not a grease pencil material, so that won't work. Yeah, that makes sense. But we can select the grease pencil materials. Like in this case, it's a dot. So I need to go to another object and... Oh, wait. Oh, it is showing the grease pencil materials. So it can show the regular materials, but also the grease pencil ones. Oh, and if it's a fill, it'll actually fill. This is very interesting. That leads to many possibilities. I will need to play around with a lot of that. I haven't used grease pencil much, but this is something special. Let's go. Let's add in another material slot for the dots and edit that while that's on here. Unfortunately, I can't add the grease pencil material to a regular object, so I need to edit it on here. So it's dots. Can I change how... Oh, the dots are only on the points. So if we resample curve. Yes, there we go. The dots are only where the points are. And also let's set radius, curve radius. This is going to be very fun. And then we could set so that the parameter, the spline parameter controls the radius. Many things that I will need to try out. So here, as we can see, the dots are very sparse, and then they become more, and you can control that just by the point count in this case. And I wonder if that can change. So we have the line type to be dots. Oh, they could be squares. Okay. Dots. Oh, wait, it could be also... It doesn't have to be those. It could be something else. Style, solid, or texture. That's really cool. I'm looking forward to playing around with that. It can be a holdout. Base color can be whatever you want. I wonder if you can control the color with an attribute. I'll need to try that out. Or is there a grease pencil color data type? There's no, there's just opacity. There's curve type, cyclic, material index. Okay. Solid, texture, squares, line. And you can enable the fill, which is a material thing. Okay, so that means it's very, very... Now you can just create comic bubble generators, and it'll work very well. And the color can be anything you want. Can you... I'm still... Oh, a few other things in the UI. The hex code is now shown right here, and you can copy it and set it. It's always available, and you can use the color picker on that stuff. A nice UI change, and the circle was made a little bit smaller when you are not using it. Okay. Let's make the colors at least somewhat complementary. Yeah, I really need to use grease pencil more. I really have not gone into it. Oh, use nodes. Okay. I don't think you can use an attribute in grease pencil. I don't think. I will need to research that, but that's very cool. Okay. So you can set the attributes and all that cool stuff. There we go. So there's that and the opacity. So if I store a named attribute, which is in this case opacity, yes, we can set it right here natively. That is very, very nice. So in that case, I can make it so that there's several colors overlapping, and then geometry node decides what parts are opaque and which parts are not. Very cool, very cool. And then, oh, that's not showing up for the fill. Yeah, okay. Interesting. Okay. Is there still hope for the physics nodes, or are they totally scrapped? If you're meaning the rigid body physics, those will not be in Blender 4.3, but they are still being actively worked on in the branch. Even yesterday, they got some new work done. Do we have subpanels already? And do you know if the devs plan on exposing the enums of built-in nodes as sockets anytime soon? Subpanels, unfortunately, are not in Blender 4.3. I am hoping they will be in the future. From what I know, from the little bit of modding that I've done, they are already possible. Like, if you go and edit stuff in nodes, you can make nested subpanels. And they're not that difficult to do. I think it's just a matter of finding a way to make them work with the node group creation and UI and all that stuff. They are 100% possible. It's just a matter of implementing them, which I do hope they will be, because that'll make like my particle system a lot easier to use. One panel is very nice for organization, but like with modifiers, nested node panels would be very, very appreciated, especially if we're working on like the old particle system. This has panels upon panels upon panels. Or here, like here, there's 2 levels. Yeah. Like in here, the physics tab has 1 main panel and 3 subpanels. So at the moment, they are in the code, they are possible with built-in nodes. I'm not sure about modifiers, if modifiers support them yet, but potentially in the future. It's just a matter of when the devs have time to do that. Okay. And the enums. So these ones, I know one of the developers has replied to me on Twitter saying that it is planned. I believe it was, I'm forgetting who it was. It was a while ago. But at the moment, there's no active development on that. Some developers are looking into like if the enums should be stored in the actual node file or a more general file, because of the storage stuff. I would not expect that in Blender 4.4. So actually, I shouldn't say that. I don't know the status of its development. It is planned, but from what I've heard, it's not a trivial thing. Okay, I don't know if this sounds dumb, but being able to use shader nodes for the grease pencil materials would be huge. I can't imagine the amount of brushes you'd be able to create with that. That would be cool. Well, I don't know how how feasible that would be with the way grease pencil works. It's very much its own little unit inside of Blender. I mean, if it has a normal and stuff like that, and it's already showing in Eevee at the moment. It's just, right now, we can just see it. The opacity is working. But I think it would probably be rather difficult to, fairly difficult to make work inside of, like, a proper rendering engine. But that would be cool, because I have, like, trails and stuff like that I would like to, have a very efficient drawing method for that, because right now having to change the curve to a mesh is rather expensive, and the curve data type needs a lot more. Wait, which one is it? Where is it? Curves, yeah, the fur, or the actual curves data type that's used for fur. At the moment, it's rendering in Eevee, or at least Eevee Legacy, and in the viewport is not great. It does not support the radius per points like Grease Pencil does, and there's a few other weird caveats with it. So if we could do trails with Grease Pencil, that would be amazing. And actually, right now we can. It's just a matter of, you know, it'll just be an overlay, which I think for quite a few people will be fine, like the non-photorealistic or the kind of cartoon area of Blender, which there's a thriving stylized community in Blender. Just recently, there was an entire Sonic, it's a mini-series, an entire Sonic mini-series. The first episode was 6 minutes. It came out this week. I would highly recommend it. It's really good. But it was made by the official Sonic company, I guess. And it was all done inside of Blender. I wonder, they may be using, what is it, Goo Engine? But I am not sure about that. But I would recommend it if you want to see a nice production made in Blender. Let's see. I wish I had a developer to ask questions about the code, but I don't want to constantly bug them. Otherwise, I would be trying to add things myself. Yeah, the developers, I would I wouldn't recommend going to them for the tech support side, but there are communities that could probably help you with that. The Arendelle server has has quite a few people that edit the code in there and do little experiments here and there. So I would recommend that for asking about help. There's a lot of knowledge in there. Unfortunately, I have a hard time understanding the code. I do as well. I do not come from a programming background besides, well, experiments here and there and some little projects. I've done the make a ray tracer in Python before, but nothing too complex. Blender add-ons and all that, you know, that's fairly straightforward. It's just like, oh, you get the list, you do this, you set the file output and all that. But nothing as big as actually making a node. I've modded nodes before, and I technically have made my own nodes, like the parent object node, which unfortunately I don't have time to work on, and that also could potentially have dependency graph issues, so I'm not even sure if it's possible to make that. But the Blender code is difficult. And actually, with the named attribute node, I did do a little modification where it would have the full space range here, but which was fairly easy to do. You just go and add an hide label to the thing there because that's supported. But putting in the gray name input here, I was trying to find out how to do that, and that was very, very difficult just because I'm not good at navigating the layers of the Blender code. But the developers did it, and it was very cool. Actually, looking at the commit, I learned a good amount of stuff. So, yeah, another reason to like this change. It is very, very nice. One of my favorite changes in 4.3. Okay. Awesome that geometry nodes development is coming along well. Do you know if we will get the option to toggle input visibility for groups or modifiers? Hiding stuff on the go would be nice. That is planned. Not for Blender 4.3, but that is planned. The dynamic socket visibility, where if you have like a switch node and there's inputs here, like I think, let's see, hide and modifier and single value, yeah. Layer selection. Oh, that's a grease pencil thing. From what I've seen from, I forget if this was a developer mockup or a community mockup. You would just have the ability to toggle dynamic socket visibility, and if the node was not being used, either like with a switch node that wasn't set to true or something like that, it just would not show up. Which is, that would be really good for assets, because like regular nodes like this, when you switch the data type and the vector inputs go missing, they technically still exist, always exist, but they're just hidden. So getting that ability in node groups would be a huge step forward in geometry node assets. Like for, I don't know, a particle system or something like that, being able to switch between different modes, like, oh, I want to edit the angular velocity or the regular velocity, or I want the rendering to be aligned to camera, and this and that. Being able to show context-aware settings would be a very welcome and useful change. It is planned, but I don't think it will be in 4.3. I was trying to figure out how to turn a field into a texture to offload to the GPU using compute shaders. That is a challenge. You have chose a challenge. That would be quite the feat. As far as I know, geometry nodes and the GPU do not play together. Turning a field input into a texture. In theory, like, there is the texture editor, and I wonder if that uses the GPU or the CPU. I don't know. It is very old, so that makes me think it uses the CPU. But that would be interesting. That would be interesting, making a create texture node. And that would... this is... I don't mean this in any kind of serious manner. But, like, being able to make textures using geometry nodes, that would be interesting. The texture editor I have almost never used in my 8 or to 10 year time in Blender, or I forget how long I've been using Blender. I think it's in the range of 8 to 10 years. I'll just say 9. I have never seriously used this at all. The only time that I've used textures have been for the displace modifier, which if you were able to edit that kind of stuff, that would be very, very interesting. But that would be, I guess, wishful thinking to a degree. So for a recap, for those who just joined, I've gone over the changes in the Blender 4.3 geometry node section. It is the biggest changelog in Blender 4.3, and there's also other cool things that I would recommend looking in the Blender 4.3 release notes, like the ability to dock different areas. Right now, you can just grab the corner, and then you can just move the sections to wherever you want. It'll replace an area and fill that part in there, and all that cool stuff. And also, the separators now have a bigger hitbox, which I know people have been wanting for quite a while. Because just being like, oh, where's the thing? Now it's just like, oh, you're over here. You can select it very, very easily. So some very nice UI changes are coming in the future. I forget, can Grease Pencil be in 3D or is it only 2? Yeah, no, that could be 3D. Yeah, let me just do a quick overview for all of it. Did I accidentally delete no, okay, that still is there. Okay, let's go over to here. So here are all of the new nodes and changed nodes. So you have the gizmos, you have the set geometry name, the warning, the hashed value, the integer math node, the for each element zone. That's a big one. That will allow for many cool effects, which I will experiment in a little bit. Grease pencil to curves, that's another big one. This Blender 4.3 has a lot of major updates. That will be very, very nice. Gizmos are a big one. Warnings are a big one. Very, very useful. For each element is a big one. Grease pencil curves is a big one. And for me personally, the string inputs for the named attribute nodes is a big, big one. So that's very good. Right, I need to experiment with the for each element zone. Also, very nice quality of life changes, the node warnings, the default node group size, the file path type for the string input, and just the string inputs being wide. So many good things in Blender 4.3. I'm very, very excited about it. Yeah, okay, so I guess with all of that, maybe I can pull up the rest of the changes and go through them, but I want to try one more thing with the for each geometry element zone. With that zone, like I've shown the attribute text, I've shown plexus in the past, which is very easy to do nowadays, and just as efficient as the very difficult to set up ones, just as fast. Let me go and use let's distribute points on faces. Distribute points on faces. There we go. Let's set this to be a big, rather big amount. Oh, there's density max. Okay. Is that new? Or am I tripping? I don't remember that input. Is that for poison disc? Yeah, so that okay, so that works for poison disc. I think distribute points on faces may be a tad broken at the moment, because that part is not doing anything. That may be slightly broken. And then that part does go up, but it's not being limited by the density max. Maybe that's still being worked on as I got this new version of Blender. Density factor. Yeah, this node seems a bit broken at the moment. So I'll just use it for its base inputs, unless I'm missing something major. Okay. Now let me use the for each geometry element zone. because I want to try making a relax node, a proper relax, or let's use it, no, let's go fancier with this. Let's have all these points in a simulation zone, and then make it so that these points move away from each other. So in this setup, we can do that, and I guess I'll need to figure out how to do the attribute part of this, because I'm still... Oh, right, no, I need to pass the attributes up through here. That's why I forgot about. Okay, so slight correction with my previous test. If you want attributes on the preceding geometry, that's why there's the spacer there, you need to connect it up to here. That's what I forgot. My apologies, everyone. I forgot about that. Need to apply my critical thinking skills. Okay, so for this, I'm going to make the points move away from all the other points based on their distance. Before, you can use the index of nearest node, but that would only give you the first nearest. But with the for each element zone, I can look at all of the parts and then sample it in a more efficient manner than before, because I guess technically you can do this by duplicating the geometry to the power of 2 and then doing this. But that would be much more inefficient than this, and in the future when lists come out, it will be even more efficient with the possibility of KD trees, which is a cool little piece of tech. But here, let's go and use a set position node after this. So what I'm going to do is use an attribute statistic node. Okay, let me make sure I have this, if I correctly have this. I saw someone do something like this, where, okay, we get a position. We pass this in from here, which is a singular value, and then we get the distance between the original geometry and all of that. And I'll use a subtract node. And we will do that, and then we'll get the mean for all of those. Well, we do a calculation for all of that, and then we pass that through to here. So we can get the offset, and then we pass that into the offset there. I think... Wait, let me think about this real quick. No, we want the sum, not the mean. We don't want it averaged. So let me hide all of that. We may want the selection input because right now it's still calculating on the original element as well, but we can compare the indices to make sure that doesn't happen. Okay. So I'll make it so that if the length is over a certain distance, then this will scale to 0. Okay, I am unsure if this will work, but let's go and give it a try. So there we go, smoother step. Okay, something is not working correctly. Things are disappearing. What is not working correctly? Does the for each zone not work with the other, with everything else? It should work in theory. I don't see why it wouldn't. It's not appearing. The geometry is going in through there and coming out with no changes. I think the position offset might be working. Yeah, the position offset is working too well. Yep. Okay, so let's set this to be 0.1. So here we can see, oh, those are still moving way too fast. So what I'm attempting to do is make it so that, yes, there we go. Okay, it does work. All the points are being pulled towards each other properly. So here, all the points are looking at all the other points and getting pulled towards each other with a kind of gravity-like appearance, or gravity-like behavior. Now, let me make it so that they'll try to repel from each other. In this case, they are trying to relax as much as they can. They're moving away from each other. Actually, let me normalize this. So that, and I don't need, let's set that to be linear. In this case, they're all moving away from each other. And look at that. That is so stable. So now, in this case, as we can see, they're all guaranteed to be equidistant from each other. Now, this is still a somewhat expensive way of doing this because it's still n squared. So if I wanted to set this to be like 200 density, this will start lagging out a bit. But as we can see, this just wasn't efficiently possible before. Like something like this, that did not work well. But here, just a very nice scattering, because before you would have to use the index of nearest node or like duplicating the geometry like the old plexus method and then doing that, which was extremely inefficient. But this should be the most efficient method so far. And then I could also make it so that let's try this, where they will try to be a certain distance. Let's set it to be 0.1. I have screwed up. Okay, that's not what you want. There is the slight issue where... Oh, no, yep, that's the issue. I need to put in the little caveat that it won't calculate on its own index. So, this is still a little bit of a workaround until we get lists, but don't worry about that. This is the best method we have so far, and it's not bad. This is not too many nodes. Let's make an equal to node. We just need to say if the index is equal to yourself in this current for each loop. Do not. Yeah, not equal. We want it to be... Wait, where's not equal? There we go, not equal. It was just a little bit hidden. Let's hide all that. So right here is, I guess... Okay, it's still freaking out. Let me make this a lot less than before. Interesting. So that is moving away. Like, look at that. Like, that pattern is so nice. So nice. I don't know why it's freaking out. Like, it's moving away, and then it settles. But once it stops settling, it should move back. Like, there, I'll just keep going out into infinity. Yeah, I think I've done something wrong. Because in previous things I've done, like it should be repelling. Like here, but that just zooms away. Okay, let me think about this real quick. If I set this to 0.01, we'll just be able to see what happens normally. Here, let me set this to be a regular range. So if it's within a length of 0.1, it will move away and then it will stop. So if it's above that range, I'll try to go back. So we'll set that range to be between that and that. And it's really trying. But I don't get what I have done to make it freak out. Maybe it's that. It's also very interesting that all of the gravity is working like that. If anyone knows what I have done wrong, because it must be something really stupid. Oh, wait. No, the gravity needs to become less as they go away. I think. So right here we have this range, but we need like a max don't calculate range. Because we're kind of still doing this in the inverse, where all the other points are calculated, and then it does it on the main one. So let's set that to be like that. So here, there we go. There we go. Quick fix. So here, if it's outside of a little... Oh, it's still trying to collapse. It's still trying to collapse. Maybe I need to make it so that it can't go further than the actual distance. Yeah, just put a max clamp on that. So we can use a... We can use the length and then set a maximum for the movement. Or here, let's multiply these two and then just as a float, and then we can use a max. So max right here, put that into there, and then we could put that into there. There we go. Takes a little bit of, knowledge. But this is a building block node for the for each zone, so I'm very glad that we have this building block. Oh, and I should also mention, I forgot to mention this before, but it's been the creator of animation nodes and one of the leading developer of geometry nodes, Jacques Luc, has now been working on procedural nodes for 10 years, as of, I think, yesterday or the day before, which is very cool. Geometry nodes has been the cornerstone of my entire Blender career, and it's very cool to see its development over time. Like, 8 years ago, or no, probably 6 years, 6 or 5 years ago, I was using a bit of animation nodes because it was very cool. Did I screw something up again here? I think I did. That's because it's max when maybe it should have been a min. Yeah, there we go. Okay, there we go. It's still freaking out a little bit, but as we can see, the groups here are very nice and evenly spaced. I could always divide the effectiveness by the distance. But here, as we can see, the gravity, in this case, is working very well. Like, this is pretty much the best gravity sim I've seen so far. What else? So that's the min distance and all that. Here, let me make this a little bit better. So let's use a multiply node so that I can set the effectiveness of all of this. Now, I know the setup is a little bit daunting. There's a lot of wires going around, but it's pretty much the same if you were using other types of nodes for this. So I'll set this to be -1 and 1. And then I'll divide... Yeah, I'll set it so that the range is divided by the length. Do I need to square that? I forget if I do need to square it. Let's set this to be 0.01. I think I may need to square that. Divided by the power of 2. Here, let's just try this one. Power of 2. It's trying something, but it still seems like it's trying to overshoot. Which I'm trying to think. You can see that the parts are gravitating to each other, but also things are acting very odd. So here, I'll figure out the actual way of doing this in the future. Ooh, that's cool. But that is not how it should be. Yeah, something with the attraction force that's messing up royally. Okay, we're at an hour right now, but I think I could go for just a little bit longer. Okay, so right here, yeah, why is the oh, that's because that's supposed to be a multiply. There we go. I switched between the different length parts. There we go, and then if that's set to be too much, you know, if the increment is too high, they move past everyone else. So now that should be good. So 0.1, yeah, they freak out if they're too close because, you know, just how they move. So if I set that to be 0.01, we can see that's much more general. And we can see, oh, there, that's, oh, dang it. When they get too close, they don't seem to be able to move away from each other, which is unfortunate. Let me set that to be like that. I want them to move out, have plenty of space, and then, yeah, surface tension. It's partly working, but I don't know why it's still... Oh, wait, that's why. No, wait, no, that's not why. Why? I'm taking the length, mapping the range. So if it's below a certain point, it'll set this... It'll just output -1. It won't be the actual length because we're normalizing it. Here, let me put this over here. We're still normalizing it. So maybe the force just needs to be less? Or maybe that just needs to be less as well? Force will always be 0. Oh, maybe I need to make it so that... Yeah, okay, the force will always be the most. When it's... No, that shouldn't be the case either. Okay, let's make that bigger. Oh, wait, no, that's why I needed to. Okay, I just need to make it so that that was... Not 0? Wait, why is it working now? Oh, maybe because of the effect. Yeah, that's why. So if I set that to be 0.1... Hmm. Okay. So the minimum distance should be... Oh, wait, maybe I need to take the length for the repulsion force. Maybe it needs to be the length minus the desired length, and then that would be the thing, so that they are always a set distance away from each other. Yeah, let me try to implement the attraction and repulsion forces separately, so that if they're within a certain range, say 0 to 0.1, the repulsion force will be 0.1. Let's set that to be like that. So in this case, yep, they should be attracted, so I set that to be negative. So now they will always try to be at that certain range, which works out very well. And then, yeah, we can make the range more like that. It's unstable, which I'm slightly surprised by. I thought it would be slightly more stable, even with all the... Maybe it just needs more people to look at. Because when it starts off like that, it's a little... I don't know. Maybe it needs to be like 1/10. There we go. Yeah, that's a bit better. But maybe 0.5? No, we still... There's a point where it still does the wobbling, even with all the neighbors next to it. That seems to be stable. Yeah. Okay, and now for the repulsion force. We'll just go and add these two together. So for the attraction force, we want that to be from there and there. So if it's too far, it'll be 0. And there we go with that again. It's very cool, don't get me wrong. But I'm still slightly confused with what I have created. Ever so slightly. Let's see. Do you prefer nodes in Blender or Houdini? I started to play with particles in Houdini and think nodes there are really hard to learn. I do prefer Blender. I still don't know whether or not it's just a result of me being in Blender for so long and Houdini. Like, I use Houdini occasionally, but it's not... Yeah, I'm very confused as to why that's happening. Like, they combine and then they just freak out. Like, there's not even velocity happening here, it's just setting the position. When they... Wait. Do I need to take the sum and then divide that by 2? Like, the end result, I just divide by 2. No. Yeah, no, I don't need... It's not the mean, right? No way. It might have been the mean. But no, the mean wouldn't work because it's... Can I do a weighted... No. I'm already doing a weighted average by... Or no, not a weighted average. I'm already multiplying everything and then just stacking the data, so I don't need to do, like, the accumulate field method. The sum should work. It should not need to be a, Like, if we set this to be -1... Yeah, no, that's just... The attraction force is too powerful and everything else is not powerful enough. That's set to be 2. What am I missing? Because I'm missing something big. Oh, wait, no, I think I might know. For the repulsion force, right now it's very strong at the beginning, but I need to make it so that it fades. Yeah, it needs to be like a ping pong. Yep. Okay. So I need this to be between what? Yeah, this range, and then ping pong. 0.5, so that it'll not be powerful at the furthest amounts. Let's make this a sum again. And set this to be like 0.01. So in this case, we should have... Nope, it is still not functioning the way I want it to. Maybe that's because of this. There we go, okay. That's a little bit better. You can see that we're almost getting what I want, but I don't know why it's so incredibly violent. I'm still not sure. Let me think about this real quick. Let me just unnormalize that and see if... Okay, that stabilizes very nicely. Then maybe... Do I want the repulsion force to always be half of the length? Okay, let's normalize this again. It should be the length minus... The length should be the length minus... Or the radius of the particle minus the length. So let me try that. So subtract... subtract, regular math, subtract. So the radius, if it's 0.1, that'll make it a negative. So in theory, everything's nowhere to be found. So that to be that, okay. And I guess I could divide that. No, maybe I've just sunk too much time into this. Maybe I have. Oh, and wait, I added 1. That's another reason why I would be freaking out. Divide by 5. Let's set that to be -5. Okay. I think I'm getting further away from the answer. Let's try out this one. Yeah, we are getting further and further away from the answer. Well, let me just set that to be scale, and then I just need to map range. Invert that. Let's just get the basics back, the repulsion force. And then I just want... Okay, there we go. Okay. We are back. So that part is working very nicely. N-body nightmare incoming. Yeah, at the moment it is still an n-squared issue because it's using a 4H node. But it should be parallelized a bit, so it should be faster than that. But when lists and KD trees come out in 4.4, that should be the most efficient way possible of doing this. And also, I should be doing this in the 3rd dimension. So let me get points in 3D space, because I should have been doing that this entire time. That would look so much cooler. So here... Whoa. What the heck just happened? I mean, yes, it's in 3D space, but also, why'd they spread out that much? Or are there just way too many in that area? Do I need to actually clamp the end result? Do I need to clamp the end result? Let's see. Let's set this to be very, very small. So that, yeah, there we go. Okay. Now this part will be repelling from each other. I'll need to look into this off stream. And then when they're attracted, they'll do their job. So let's attempt to do the attraction force again. So we have... Oh, wait, is... No, that wouldn't be the case either. Here, let me just try adding both the forces up together. Or maybe I'll even use a separate attribute statistic so that the things cannot overlap. Maybe. As we can see, it is trying to work. Despite, there we go, okay. That's at least part of it, even though I think it's, such a light effect that you can barely see it. And, okay, it's collapsing again. But, yep, it's collapsing. Let's go, okay, enough of that. Let's go and add in some noise to the offset so that we can see, you know, some of the cool stuff with it. Let's do an add, scale. Okay. We still have 34 people here. Hello, everyone. I know these streams have been fairly impromptu and not with a lot of prep. That's mainly due... Oh, that's looking so good! Whoa, okay. That's mainly been due to my work. Work has been very... it's been good, but very, very involved. So my time for streaming and for just other stuff has been very, very low. I've been prioritizing having fun in my off hours rather than doing Blender 24/7. So, you know, I know you guys understand all that. But yeah, just in case you were curious. That's looking so good. Like before with the other stuff, that would be so incredibly difficult to do in a stable manner. Because actually right now, and I completely forgot about this as well, let's have ones with different radii. Because that's another thing with the index of nearest node, you just can't do. Straight up can't. You cannot make it. Am I still... Oh yeah, I'm still in the example blend file, so I can save this. With the index of nearest node, if things have different radii, that is really not too great. Because that means that if one particle is smaller, but it will mean that it's closer to another particle. But if there's a bigger one that probably should be colliding with another particle, the smaller one will always be closer, which means that it just will never resolve properly. So in this case, since we have all of these, and we can give them all of them their like mass and stuff like that, like in this case, I will multiply... Do I multiply this by... I can get the radius from every point, but I think in this case I'll just do this one as well. So I'll multiply this by the radius. And I could also incorporate the radius for each point in here. So in this case... Oh god. Yeah, no, the radius isn't even that high. Oh wait, it's collapsing that part. Okay, so let me multiply this one by the original radius. I'll need to clean all this up. This is my first test with all that. We can see right here that the sizes, at the very least, are kind of working. The attraction force and repulsion forces should be okay. We can even see orbits occurring. I'm unsure if the sizes are working incorrectly. I would expect that they are very, very incorrect. And yeah, let's multiply the radius by 2. Let's do 4. So in this case, at the very... Yes, okay. Is it working? We need... Oh wait, no, I need to add these two together. Sorry that this is becoming such a huge mess. Again, I'm figuring this out as we're going along. Because I have not researched an actual gravity equation. So in this case, this is taking the radius of both the parties into account. That should be pretty good. And then, for this part... I can also do that there. But as we can see, that is a bit too much. So let me go and do this. It's looking good, and I can also do this. So now these are acting very much like a fluid, and actually we only have, let's try 10,000 particles. I want to see when it does lag. I think we found out when it lags. I think this is an n-squared issue, where it just gets less and less efficient over time. Yeah. It seems, actually, wait a second, let's look at node timings. Ah, that is 37,000 milliseconds. So this is a prime example of how n-squared equals bad. Okay, yeah, so this does not scale. Right now it is 20 milliseconds. Which actually, yeah, better the better node timings is very evident right here. So with 1000, it's at around 20 milliseconds. So, what level of math is necessary to be good at geonodes? It all depends on what you're working at. Like, I did not have a good math education. I had a very poor math education growing up. So, the math that I learned was from Blender, either by the shader editor or geometry nodes. So, the level of math that you need entering is 0. You don't need to know any math. You just need to be open to learning. Everything with this I've learned just through geometry nodes and being like, oh, okay, let's look up a gravity equation and how that's done. Let's look up how to make a rigid body physics system. That is way too complex. Do not try that. Here, I need to try making this clean because I have messed this up greatly. But as we can see, it is at least partly working. I would probably turn this into a node group. Actually, yeah, let's go and do that. Let's go and do this and turn it into a nice node group so that I can then make it better. So, node, make group. Node, make group. Apologies everyone, for some reason, it is refusing to node, make group. Maybe because it's a zone and all that. If I wanted to really make it a group really, really bad. Here, node. Let's make sure I have all this selected. Node, make group. There we go. Okay. Maybe the output here was an issue. I am not sure. There we go. So we can just do that, put it over into there. There we go. I didn't know trig or linear algebra until Blender. Yeah, basically, Blender makes you... It's kind of like, I don't know, a muscle. Math is like a muscle. If you don't do something where you need it, you won't develop it. Like, in school, if you learn a ton of math stuff and you never use it, you forget about it. But the opposite is true. Blender becomes your school. It's like, oh, what does vector math do? What does the reflect vector math node do? Blender's very good because you can see the values easily. And you can see how they change over time. And also, I would recommend just looking up the equations when you're coming along with them. Like right now, I don't know how to make a gravity sim correctly. An n-body gravity sim. So, when the stream is over, I will go and look that up. And then I will then know how to do it. That's how you do it. You just keep learning as you go. I really like how this is working, because it is so nice. But it is still an n-squared issue. There is a KD tree, which can make this a lot better. But, unfortunately, I don't think that's possible right now. In lists, it will be. So if we set this, the node timing is now 22 milliseconds. If I set this to be 2000, as we can see, that went up to 53. Which actually is... It's a little bit more than double. Now if we set it to be 4,000, this should be like 100 milliseconds, yeah. It's a little more than that as well. It is still running in parallel, so it won't be 100% to the power of 2 times as slow, but we are getting there very, very fast. If we set this to be... Or, it is still to the power of 2, but since it's parallelized, we don't quite see it as much. So here we can see, yeah, we're hitting that. We went from 100 milliseconds to 2,500. So a KD tree is 100% necessary when doing this. Do not try this in a practical situation. This is good for small projects, when you need stuff that needs to, like, a few objects that really need to be, you know, calculate things for each one of these. But it is wildly inefficient. If we go up to 5,000, we'll see that probably jumps to... What was that? Yeah, going from 4,000 to 5,000 went from 100 milliseconds to 1,000 milliseconds. That is not great. Not great at all. Let's do... Actually, wait a minute. Am I forgetting? No, that's all working as intended. Yeah. It's not as bad as it could be, though. Because for this, we're calculating... Right now, it's basically 1,000,000 points doing calculations. If I set it to be 2,000... Wait, what? 1,000 times 1,000? That's 100,000, yeah. It's this, but to the power of 2. So it's, it can get a lot worse than it currently is. So, don't go above 1,000. When KD trees come out and other optimizations, do it then. And also, you can use the index of nearest node because that has a KD tree built in. Index of nearest. So, if you have like 100,000 points, this will work just fine. Just be aware that it won't take every single body into account, it'll only give you one. Again, that'll change in the future with lists. But here's a little look into how that could look in the future. It'll just be faster. Where things actually are doing what they should. I do want to try an actual gravity sim, though. Like, usually with gravity sims, you don't have 1,000 planets. Ignoring asteroid belts. So, in that case, it should be okay. And also, using a for each loop. This is a bad idea, but we can go and display certain values for each element and actually render them, which before we couldn't. We would only be able to view them in the viewport. So let's go and take this offset value. Do I need a capture? It should be fine. Let's go and do that, and now let's actually visualize it. For each point, you will now see... this will be slightly painful. Why is it not... Why is it not moving? Oh, wait, no, that's just the offset. So I need the mean value, or no, the position as the input here. Position, and then whatever the length of this value is, I can pass in. So length. So with 2 for each zones running at the same time, it shouldn't be too bad. Except the amount of instances. Oh yeah, there we go. Oh wait, we're not even looking at it. So we don't need that. And here we go. It will be expensive because there are... What did that mean? Is 0. Oh, okay, the values are just very, very small. This will be expensive because it's a ton of instances that are then being triangulated. So, yeah. So if there's like 1,000 points each times 1,000, that's still a lot. Still a lot. But we can render it now, which is good. There we go. So again, and that part alone is 60 milliseconds. What would happen if I were to realize the curve instances? That is a mistake and a half. I think because of the fill curve node. Oh. Yep. Blender's crashing. Okay, I went too close to the sun. Because the amount of instances was... I'll recover an autosave. The amount of instances, or points, was 1,000. So the amount of instances, if I had 4 levels, 4 decimal points, and the decimal, that would equal 5 instances. So that would be either 500,000 instances or 5 million. Multiplying 1,000 by 1,000 is difficult, don't blame me. Let's go back to the autosave. We are back from the autosave. Okay, we're at 1 hour and 30 minutes, so let's call it there. And then when we fill the curve, since it's not for each instance, it is freaking out. So let's try realizing instances without that. As we can see here, it's a lot better. That takes 1/10 of a millisecond, and then they all get joined together. So filling the curve, I should do beforehand, which is still it's more expensive to do it inside the for each zone, but since we're realizing actually no, I should move both of those out of there. But then again, why would I realize the instances? Let's not worry about that. As we can see, we can now do all of that. And rendering it on or drawing the curves on the CPU and all that is expensive, while the attribute viewer node, attribute text here, is, I'm assuming, done on the GPU. And that's also using a for each loop, but, you know, faster. There we go. So I will try to make an actual gravity sim using the for each loop. It will be, again, extremely slow with large amounts of particles, just because of the n squared issue. But if I can figure out a KD tree, that would make it so that I can do like 100,000 particles in semi-real time, and 1 million particles in semi-real time. Just because that space partitioning is really good with stuff like this. Okay, I have tried it once, and actually maybe with the hash value node I can do it well. And we do have integer math, so I won't be susceptible to float point precision errors, which might have been an issue in the previous one. Because with... That might actually be possible. I'll think about that off stream. But yeah, okay, what was I doing? Let's go and add in some more noise just to see how that goes. In this case, there's no velocity, which maybe I should add. That could make it look cool. But oh, I can also share the velocities if I do store them. I'll do that off stream. Thank you all for watching. I hope you enjoyed this little exploration into the new nodes inside of Blender 4.3. Lots of very cool nodes, very, like, game-changing ones. Gizmos, the warnings, geometry names, hash value, integer nodes, the for each element, the grease pencil nodes, and my personal favorites, just because I use named attributes so incredibly often, the increased attribute space. I'm very happy that was implemented. So once again, thank you all for watching, and I will see you all next time. Oh, let me read the chat real quick. Okay. Hi, it's new features in GeoNodes? Yes. Let's see. Gravity is pretty simple. Each point should be attracted to every other point according to the mass sum of both bodies divided by the distance between them squared. Okay, so I was kind of right with the square part. I'll try to I'll try to implement that as soon as the stream ends. Nah, I'll be doing some other stuff. You need to live outside of Blender. It's interesting to see some of the quirks of the universe using math. For instance, since gravity has a divide by distance, If 2 points are near 0, then the velocity goes to infinity. I think that was probably what was happening in here. Actually, can it go into infinity, or would it be clamped by the mass? I'll have to think about that. But yeah, I really want to try different little formulas of the universe inside geometry nodes, especially like with planets now that we can do it in a non-hacky manner. Like right now, like lists will make things a bit easier, but the workflow, or faster, but the workflow will be very similar. I mean, 0 divided by 0 is just cursed. Oh, yeah. Yeah. I wonder if that can exist in the universe, and what it would do. Maybe a Big Bang. Alright, thank you all for watching, I hope you all enjoyed, and I will see you next time. Happy blending!